Hey Calculus, we're back with one more problem on the section volume using disks. And I think we'll just get right to it because I don't think we need to take too much time with this section or this lesson. So it says find the volume of the cone created when rotating this line around the y-axis. So notice this time we are going 10. There we go. We are going around the y-axis. Also notice, they do not tell us what this line is, but they do give us this kind of marker to say we want to stop here. So let's figure out what this line is. Well, it has a y-intercept of 0 and a slope of up 2 over 1. So y is equal to 2x. I'm fairly certain is this line. And let's consider what we need to do here. We are finding the integral. Now, if we're going around the y-axis, technically we're doing this with respect to y. So dy, I know. And if I'm going with respect to y, I'm starting here at 0 and ending, here at 6. Now, my radius this time is actually an x distance. So what do? Well, luckily, I can just rearrange this. X is equal to y over 2. So that's going to be my radius. Pi, our radius, y over 2 squared. And honestly, that's it. We're ready now. So let's simplify a little bit. I'm going to pull the pi out. Integral from 0 to 6, y squared over 4, all with respect to y. And I'm actually also going to pull that 4 out. So I have pi over 4 times the integral from 0 to 6 of y squared dy, which is a very simple integral. Pi over 4 times the integral from, sorry, I was not paying attention. We don't need to do that. We just need to take the antiderivative of y squared, which would be y cubed over 3, evaluated from 0 to 6. I'm not actually even going to do all the work here, but we would do pi over 12 times y cubed from 0 to 6. We would plug in 6. We don't need to plug in the 0. And when I do this and multiply everything out, I get 56.6 units cubed. Now that I'm doing this lesson, I'm realizing it's super, super short, and literally we're done, but I'm going to pause really quick and see if there's any other problems from the homework I want to do. All right, yes, we are going to do one from the homework. We are going to do number 4, which is y is equal to the square root of 25 minus x squared, and y equals 3. So as is super necessary with each of these problems, we probably want to draw a picture. I know the line y equals 3 looks like 1, 2, 3, and is just a straight line right there. So that's easy. And then this little guy right here is actually a half of a circle, the top half of a circle, specifically a circle that has a radius of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our circle is going to look something like that. Okay, that's not bad. If you didn't know what either of these lines looked like, you have Desmos, you have your calculator. You guys can figure it out. Okay, find the volume of the solid that results when the region enclosed by the given curves, okay, so that means this is the region we're interested in, is revolved around the x-axis. So revolved around this way. Now notice, in this one, this is different than the last ones we've done because there is a space between this volume piece and the actual axis we're rotating it on. Don't worry, it doesn't make it too much more challenging. But we do need to find this point and this point to integrate because this is our lower and upper bound. How am I going to do that? Well, I'm going to set these two curves equal to one another. So 3 is equal to the square root of 25 minus x squared. I get my x all by itself by squaring both sides. 9 is equal to 25, minus x squared. I'm actually going to move x over here x squared over here, and I'm going to subtract 9. So I would get 16, and I would get x is equal to positive or negative 4, which hopefully kind of makes sense with my drawing. It wasn't perfect, but you guys get it. All right, so we have our bounds, and we can start setting up our integral. I'm just going to make this a little nicer. All right, I know my integral is going to go from negative 4 to positive 4, and I know I need pi. Okay, now what is the radius here? Well, this distance is the y distance of our curve, so the square root of 25 minus x squared. But I don't really want that entire thing. I want to take away this distance right here, which is my line, y equals 3. So what am I going to do? Well, I am going to take that big distance, the square root of 25 minus x squared, and that's going to be my first piece, and I'm squaring that. And then I'm going to subtract from it all of this in here. So technically 3 squared. And this is all with respect to x. If you think about it, what I'm basically doing is finding all of this shaded area. Like imagine, I'll erase this in a second. All of this, I'm finding the entire volume using this piece, but then I am taking away from it that basically what it would be a cylinder in the x or y equals 3 place. So now that I've set up my integral, technically the rest is not anything we have to go through because, well, you guys have your graphing calculator, so you could, if you wanted, do this all on there. I'm not suggesting you do that, but whatever. But I could go through it. I'm going to pull out the pi, the integral from negative 4 to positive 4. I'm going to square this, so I really have 25 minus x squared and then minus 9. Again, all with respect to x. If we simplify, which we should, I'm going to get pi times the integral from negative 4 to positive 4. 25 minus 9 is 16 minus x squared with respect to x. I still have the pi. The antiderivative of 16 would be 16x. The antiderivative of negative x squared would be 1/3 x cubed, or x cubed over 3. And we need to evaluate from negative 4 to 4. Plug in 4, subtract negative 4, and I don't have a perfect answer. I have a big fraction. 256 pi over 3, which I'm not going to plug into my calculator. I'm just going to say that's the answer. All right. Hope you guys have a lovely Wednesday. Just kidding, it's Tuesday. I don't know, whatever day it is. Have a good day, and let me know if you need any help.